In this video, we're going to continue to factor quadratic expressions, but we're going to make them a little bit more complex in that in our last lesson, we had a quadratic expression in standard form where a was just equal to 1. And we were said, factor this. Today, we want to look at what happens if a is greater than 1, okay, or other than 1. And we're going to introduce this to you using nice whole integer values, and we'll get into what happens when they're non-integer much later in the course. We're going to explore two different methods to do this, and it doesn't matter to me which method you use. I speak both of them fluently. In this first video, I will show you a method that I call split the middle term, and then in the next video, I'll show you a method called the Berry method. So let's look at how to do it using split the middle term. So in your notes, you have an example that looks like this, that you're told to factor. And it reads 4x squared plus 8x plus 3. Now, anytime you are told from this point on to factor, you now have a couple of tools in your toolkit, and you should do them in this order. The first thing you should ask yourself is there a greatest common factor that should be extracted out first? And that is always, always, always your first question. Okay? If there's not, you could see if there are 4 terms, and if you could either take out a common binomial GCF, although that would fall under this criteria, or if you could factor by grouping. We don't have 4 terms here, so factoring by grouping is out. So, no GCF, no factoring by grouping. How in the world are we going to factor this? What we're going to do is we are actually going to get to a point where we can factor it by grouping by doing something called split the middle term. Okay? So our first step is going to be to rewrite this and leave a couple of little blanks in here. We don't know what value of x we're going to put in here yet, or what value of x we're going to put in here, but we do know that they're both going to have to add up to give 8. Okay? So we're going to go back to the tool we used in your last lesson, which is to set up your little thinking chart. And you want to think of 2 numbers that multiply to give a times c. So a is 4 and c is 3. Okay? So I'm positive 3. I'm looking for 2 numbers then that multiply to give 12, and they have to add to give the middle value here, which is positive 8. All right, so can you think of 2 numbers that multiply to give 12 and add to give 8? If you can't, you can start at 1 and 12, then you go to 2 and 6, 3 and 4. Oh, wait a minute, 2 and 6. I think they also add to give 8. So there are my 2 factors that I'm looking for that meet this set of criteria. So I'm going to put these 2 values, 2 and 6, into my splits right here. And it doesn't matter which one goes where, but I think that 2, is a good friend of 4, and 6 is kind of a good friend of 3. I mean, it could go the other way around too, but let's put them there. So plus 2 and plus 6. Okay? Now, after they've gone in there, we now have that criteria I was telling you about, criteria 2 of, do we have 4 terms and could we factor by grouping? Most certainly we do have that scenario. So, let's look at the first set of terms. What is the GCF in here? Well, numerically we have a 2, and they both have x's. I can take out at least an x, and then it runs out here. I have to multiply 2x by 2x to get 4x squared, and I have to multiply it by positive 1 to get 2x. Let's do the same thing over here. What's the GCF inside this pair of terms? Well, it looks like there's only a numerical GCF of plus 3. What do I have to multiply 3 by to get 6x? I have to multiply it by 2x. And what do I have to multiply 3 by to get 3? Plus 1. Now, this is good, because we notice that this and this are identical, and this should happen when we are splitting the middle term. We should end up with two terms that are identical here. So this is a common binomial to both sets of things that are being multiplied. We can take it out as a GCF. So we have 2x plus 1, and in order to get the line that's up above, I would have to multiply 2x plus 1 by 2x to get this set of terms, and then I would have to also multiply it by 3 to get this set of terms. And there you go. You have factored a quadratic expression that began with something other than 1 and that did not have a GCF that we could pull out to make it a 1. All right, let's try another example. Let's look at factoring this expression. Negative 8x squared plus 26x plus 24. So again, when you are told to factor, the very first thing you're going to ask yourself always, 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 always is there a greatest common factor? Now as I scan across here, I see that these are all even numbers. So I know that 2 is at least a factor. Could I go any bigger than that? Is there a 3 or is there a 4 or so on? Well, 26 is kind of the limiting one because 26 can only be created by 2 times 13. It has no other factors, whereas 8 and 24 have a number of other ones to choose from. So 2 is the biggest. I'm also not a big fan of this a value beginning with a negative value. So what I'm going to do here is I'm actually going to take out negative 2 as the GCF. Okay? And let's see what happens when we finish the rest of the expression. So negative 2 times 4x squared would give me 8x squared. And negative 2 times negative 13x would give me 26x. And negative 2 times negative 12 would give me positive 24. Okay? So in factoring, I've done the number 1 step. There was a GCF. I took it out. If I can take it out as a negative, that's going to make this a whole lot nicer too. Okay? My next step would be, can I factor by grouping? Nope, because I've only got 3 terms. So then I'm going, instead this is a quadratic expression. I need to set up my t-chart. So I need 2 numbers that multiply to give a times c, or 4 times negative 12, which is negative 48. And I need 2 numbers that then add to give the b value in here, which is negative 13. So because they multiply to give a negative and they add to give a positive, add to give a negative, what do we know about the signs of both terms? Well, one of them's going to have to be negative, one of them's going to have to be positive. And of the 2 terms, the larger one is going to have to be negative, so they add to give a negative number. All right, 48 has a lot of factors, okay? I'm not going to this time start with 1 and 48 because in my head I know that there's no way they can add to give 13. Half of 48, or 2 times 24, again, there's no way they're going to add to give 13. So I'm kind of doing some of this work in my head to reduce some time. What about a factor of 3? Well, 3 and 16 can be multiplied to give 48. So what happens if I put the negative with the 3? Well, then they would add to give positive 13. Close, but not quite. So that would mean that the negative has to go with the 16 instead, so that they add to give negative 13. So here are my 2 factors that I can use in splitting the middle term. So I'm going to rewrite this as 4x squared, and instead of negative 13x, I'm going to split it into 3x's and negative 16x's. So let's do plus 3x minus 16x. And again, the order doesn't matter. And there you go. Now I have 4 terms. We've already dealt with GCF, so it looks like factoring by grouping is my next step. And this negative 2 out in front is just hanging out. Okay? It's still there. We'll learn about its significance in future lessons. What's a GCF here? Well, it looks like x is the only GCF I can have. which means that this has to be 4x plus 3. And looking in here, they're both negatives. So it would be nice if I could take out a negative GCF. I think they're both multiples of 4. So let's take the negative 4 out. And we know that if we've done this right, we should end up with binomials here that are identical, and we do. So in our final step, we're going to focus on what's inside these big brackets and take this binomial out as a GCF for both of these pairs of products. So 4x plus 3 would have to get multiplied by what's left over, which is x minus 4. And there you go. You've factored it. If you were to expand it, go backwards, you should end up with this as your answer. When you have a monomial times a binomial, you would do FOIL first and then distribute the negative 2 to each of the terms that result from doing FOIL first. And like I said, you should end up with this. Okay, next video we'll look at an alternate way of doing it called the Berry method.